Our topic today is rolling motion. Our topic today is rolling motion. Wait a minute, give me a second. Okay, so our topic today is rolling motion. We already discussed about rolling motion in the last class. In the last class, what we have discussed about rolling motion, that we know how to find out the velocity at different point in a rolling object. If the object is in pure rolling, then how to find the velocity of each and every point on the object? That is what we have discussed. In pure rolling, the velocity of center of mass equal to r omega normally. That is what also we have discussed. Now today we will discuss some other things. Rolling motion. Now we will discuss both the things, that is pure rolling and that is impure rolling. Now what is pure rolling? We already know, we have discussed yesterday that in pure rolling, normally the velocity of center of mass is equal to r omega. R is the radius of the object, omega is the angular velocity. In impure rolling, what will happen is that velocity of center of mass is not equal to r omega. Suppose we take some examples. I will take a very simple example. This is my ground and this is a ball on the ground. The ball is stationary. We hit it with a cue. It is a billiard ball. Instantly after hitting from the cue, the ball got an impulse and its center of mass gets a velocity v naught. The ball is having a linear motion with a velocity v naught and it is not rotating. Or we can very well say that ball is rotating with omega naught and omega naught equal to 0. That means ball is not rotating. Out here v naught is not equal to r omega. So this is impure rolling. This is the example of impure rolling. Here if you see the point of contact from the ground, it is moving with respect to ground, in relative motion with respect to ground, because v naught is the velocity of every point towards right. So slipping will be there. Slipping will be there. Slipping will be there, that means friction will be there. Friction will try to oppose the relative motion. Friction will be in which direction? Friction will be backward in this case. What will be the value of the friction? Very simple, value of the friction is complete friction, that is mu normal. Normal in this case is mg, so it is mu mg. So in this case, friction will act. It will reduce the energy. Now, it will do two things. It will reduce the energy, and as you can also see, it will produce a torque about center of mass also. Slowly, omega will increase and v will decrease in such a way that finally v becomes equal to r omega and we achieve the condition of pure rolling. Right? Out here, v naught is greater than r omega because r omega is 0. So the velocity will decrease, omega will increase in such a way that finally v becomes equal to r omega. And when v equal to r omega, at that point of time, the body will come into pure rolling. There will not be any slipping, energy will be constant, there won't be any change in v, there won't be any change in omega. And if the objects are perfectly rigid, there is no air drag or anything like that, object will roll till perpetuity. It will roll till infinite time. Normally in practical life, it is not the case. So there are deformations between object and ground. Air drag is also that the object stops. But we will take a very simple situation. Object and ground are absolutely rigid bodies and there is no air drag as such. So once the object attains condition of pure rolling, that is v equal to r omega, there won't be any further loss of energy and object will roll till perpetuity. This is one case. We can take one more case, that is, this is the case. You take a ball in your hand like this, rotate it by hitting it somewhere. Now the ball is in pure rotation and slowly put the ball on the ground. Now ball will be having a omega. Let us say it is omega naught. but linear velocity of ball will be 0. So in this case also, V naught is less than R omega. It is not equal to R omega. This is again impure rolling. Friction will act in which direction? Friction will act against the relative motion in front direction. Value of friction will again be the same, that is mu mj, that is mu normal. And what will happen? Now friction will increase the linear velocity, decrease the omega till the point there is V equal to R omega. As soon as we get the condition V equal to R omega, there won't be any further loss of energy. Body will roll till perpetuity. So this is the concept of impure rolling. Now, suppose if we want to see at what time impure rolling starts, the body is doing starting impure rolling. At after some time it starts pure rolling. Now, what is the time after which the body starts pure rolling? What will be the final velocity, final omega? How do we find it out? So let us take one example, that is any one of the examples, and try to find out that how will the body will be doing the pure rolling, right? So I am taking example number 1, and all other examples can be solved by the same method, So if I take example number 1, this is the example. Now out here, if I do a simple force balance, we can very well say that F equal to ma and A equal to F by m. Or we can write this way also, that mu mg equal to ma, and then A becomes equal to mu g. And we can very well say that V equal to V naught, V plus AT, A is mu g minus mu gt. This velocity at any point of time, linear velocity. If I talk about torque, then Fr equal to I alpha. You can take it is a sphere. Sphere I is 2 by 5 mr square into alpha. Then what will be the value of alpha? I can put the values out here. F is how much? Mu mg. Mu mg divided by 2 by 5 mr square into r. F r divided by I, that is alpha. Mm will get cancelled. 1r will get cancelled. It will be 5 by 2 mu g by r. That is alpha. So what will be omega? Omega equal to omega naught plus alpha t. Omega naught is 0. No initial angular velocity is alpha t. That is 5 by t mu g by r into t. When body attains pure rolling condition, V becomes equal to r omega. We can put V, that is V naught minus mu gt, equal to r omega. That is the condition of pure rolling. That is 5 by 2 mu g by r into t. I will solve it out now. This r will get cancelled. This is 5 by 2. This is 1, 2.5, and 1, 3.5. That is 7 by 2, right? So V naught equal to 7 by 2 mu gt, So T equal to 2 by 7 V naught by mu g. After this time, the pure rolling will start. And what will be the omega at that point of time? Omega is given by this thing, 5 by 2 mu g r by t. We can put the value of t and we can find the answers. T is 2 V naught by 7 mu g. Now mu g get cancelled. 2 get cancelled. Omega will becomes equal to 5 by 7 V naught by r. And what will be the final velocity? V will be r omega, that is 5 by 7 V naught. So now we know that final velocity will be 5 by 7 V naught, little less than the original velocity. Omega naught was 0. Final omega will be 5 by 7 V naught by r. V equal to r omega. Body will roll till perpetuity. So this is the way we can find out the final velocity for each and every example. If V is not equal to r omega, slipping occurs, friction is mu mg normally or mu n, and we can do these activities. Any doubt? Anybody can ask me now. Any doubt? Anybody can ask me. Anybody can ask me any doubt. Okay. Now, if somebody says to me, what is the energy at any point of time? I will rub these things out now. What is the energy at any point of time? And the energy initial, you can definitely find out, that is half mv square in this case. Energy final is half mv square plus half I omega square. And then we can say energy at any point of time is half mv square plus half I omega square. V also we know, omega also we know. We can find out the energy. If somebody says to me, find out the work done by friction. Work done by friction. So work done by friction will be how much? That is work done by all the forces equal to change in kinetic energy. Now mg will not do any work, normal will not do any work, they are normal to the motion. They will anyway cancel each other. So work will be done only by the friction. It will be delta K. That is K final minus K initial. K initial is half mv naught square, only linear motion. K final will be half mv square plus half I omega square. So that is my K initial and K final. Right? So we can find out the total work done by friction also. If somebody asks us if friction is doing what kind of work, so friction is doing what kind of work? Friction is doing what kind of work? It is doing some positive work, some negative work. Positive work, it is rotating. It is rotating the object. And negative friction is this such velocity, it is reducing the velocity. So friction is doing both the works out here. We cannot simply say that work done by friction will be equal to mu mgx. That will be the negative work. But friction is rotating the object also, na? For example, energy at any point of time will be half mv square and plus half I omega square. If we differentiate it will be dk by dt. dk by dt will be a half mv square, 2 will get cancelled. It will be mv dv by dt or mva, or it will be again I omega and d omega, but that is alpha. What will be mva? Ma, that is the net external force, that is friction, F into V. But that is minus, because A will be minus, so it will be minus. It will be what? I alpha will be torque, and we can say torque equal to I alpha equal to Fr. So it will be Fr into omega. Now, power, that is the power thing. Friction is providing two kinds of power, one positive, one negative. Negative, it is reducing the velocity. Positive, it is increasing the omega. Right? So overall, you can say that friction is doing two kind of work, one positive, one negative. Positive, it is rotating the object. Negative, it is reducing the velocity. So net to net, we have to combine both the things to arrive at the final work. Or you can simply say that a work done by all the forces equal to change in kinetic energy, K final minus K initial. We cannot use F equal to simply mu mgx. That is F force new displacement. That is the negative work. Positive also has to be there, no? So Fr into omega also we have to take into account. Okay. So that is the work done. So in this motion, you can find out the work done by the friction at any point of time. The value of the friction you can find out. We can find out angular acceleration. We can find out linear acceleration. We find out velocity at any point of time. We can find out omega at any point of time. So our this thing is complete, right? So impure rolling, one example is complete with all the details: initial velocity, final velocity, all the forces, energy, and acceleration. Let us take 2-3 more examples to clear all the concepts so that we should be able to solve all the questions, right? all the concept, all the questions. So in this example, we have assumed that ground is not moving. Suppose ground is also moving, then what will happen? If ground is also moving, but then what will happen? You will say, sir, ground never moves. So to move the ground, what I will do, I will take a plank. This is my ground, and I will take a wooden plank. This plank is moving this side with a velocity v, and here I put my sphere. Here I put my sphere, right? And here, suppose the question says here it is pure rolling. It is moving with a velocity v, center of mass, sphere, and rotating with a velocity omega, that is omega naught, that is angular velocity. Out here, what will be the relationship between v omega and the velocity of the plank? I say it is v plank, and I say it is v center of mass. So let us write it very clearly, v center of mass. Concept is exactly same like pure rolling motion. It is pure rolling. So at point of contact, the relative velocity has to be zero. The point of contact relative velocity has to be zero, right? In the last example, the ground was not moving. The point of contact velocity of ground was zero. Velocity of the above object has to be zero. In this case, at point of contact, this plank is moving to the right. So Planck velocity at point of contact, that is at this point, is Vp. So the object velocity has to be Vp, so that there is no relative motion between them. It is the case of pure rolling, right? In previous example, ground was at rest. Velocity of ground was zero. So the point of contact of the object with the ground has to move with a zero velocity in horizontal direction. Okay. So object will have velocity v center of mass this side and r omega this side. So we can definitely say net velocity towards right will be v center of mass minus r omega. So we can very well then say that v center of mass minus r omega equal to v Planck, equal to v Planck. So what is happening out here? What is happening out here? What is happening out here? Out here, v is not equal to r omega, right? Since Planck is moving right, object has to move right, right? Or the point of contact is moving right. So relative velocity between them should be zero. V center of mass minus r omega equal to v. If I extend the same example, I put one more object out here. It is moving with a velocity v top or v2 we can say. The relationship between v2 and v center of mass will be, as we can say, same thing. It is a pure condition of pure rolling. This point of contact will have same velocity for rolling object also, for this object also. So v2 must be equal to, what should I write? V center of mass and omega naught will be this side, same direction, that is r omega naught. So that is for the top plank, that is for the bottom plank. Bottom plank, top plank, this is my condition of the place where the planks are also moving. The ground is also moving, right? The ground is also moving. Perfect? Perfect? No issues? No issues. So these are the things we have discussed today. First, what is impure rolling? What is pure rolling if ground is stationary? How to find out acceleration for them, velocity for them, right? Everything for them. And how to find out energy for that case. And suppose if the plank is also moving, for the above plank, for the below plank, what will be their velocities? In the next class, we'll discuss some more examples, right? Anybody having any questions, please ask me right now. Anybody can ask me any questions. Okay, no questions. Then I think that's all for the day, right? That's all for the day.